Hey guys, welcome back to my channel TechFit, and today we are going to continue on the next level of data science project from scratch. And if you haven't watched the previous video series, I would definitely recommend you to watch them first, as we went through kind of like first of all talking about what project how can we actually select a project first of all, and then moving towards the data collection stage. Again, within the data collection, we looked at a lot of different ways of collecting the data. So for an example, we were collecting the met.no data through accessing it through the APIs. We also looked at how to collect the data through using Selenium, where we built a bot which can actually download the files automatically. We also looked at how can we use Python request module to actually extract the data through basically using the request module in Python, and based on the specific link how to download the files. So I hope you kind of like enjoyed that part of the series. Now today we are going to look at data cleaning. Within data cleaning, I think I mentioned in the last video as well, where we stopped on the data collection stage, which was to kind of go through this. There are three versions of the file. I mean, there's three different files and coming from three different locations. So to kind of make it all kind of like work with each other and have it on the standard way of all the features and the demand variable to be on the same level as well, because as we looked into that file, the demand data was on 15 minutes interval, rest of the data was on 1 hour interval. So first of all, we want to make sure the whole data it's kind of like on the same level. In the end of this data cleaning, what I want to achieve is that I should have only one file, which is one CSV file. And for your case, it could be just something like, rather than updating that in the CSV file, you can actually push it back to your database. But it should be only one table or one file that gives me all my inputs, and it gives me my final target variable, which is demand. So that's what we are trying to achieve out of this one. So what I'm going to do is I'm going to code it all out, and then I'm actually going to go through the whole script line by line, because we have to kind of move towards the next stage, which will be exploratory data analysis, where we go through how we're going to actually use this data. So as we can see in the data collection point as well, that we're collecting the data based on the site. What I will also kind of test out in the EDA section is, once we are having these multiple site data, if we can actually average all the data and then see if that actually improves the prediction of the model or if it decreases the model predictions. So without kind of wasting any more time, I'm going to start coding this class, and once I'm finished with this, I'm actually going to explain this class step by step, how the exact code is working, and then we'll execute the code and we'll see the output of this code. Perfect. So we are now finished writing our class. So what I want to kind of do is take you through the whole code and kind of explain it to you line by line how the code is exactly working. So before kind of moving towards explaining the code line by line, I want to actually show it to you the actual repository as well, how it actually looks like right now. So as you can see, we have our repository here. So if I go into the data section, within data section, I do have this data, which obviously holds all the latitude longitude points, which is the JSON files. Now I do have air grid data, and then I have met-here data, met-no data, these folders, and also have a zip file folder here. Now, in case we will be looking at more in future as well when we're doing the automation, because we do want to automatically remove any sort of these zip files as well when we are always running these scripts. So we'll take care of all of that in this stage when we are doing the automation. Right now, we're just more interested in cleaning the data itself. So if I kind of give you an example how the scripts I want them to work. So if I go into the met-here data, within met-here data, as you can see right now, we do have these multiple files. The idea behind having these folders is, or these a subdirectory, which is the clean data, is to actually take all these files, and what I want to do is I want to clean them first of all, and after cleaning them I want to merge them into one and put this file into clean data. And exact same I want to do with all of the rest, two of the files as well, which is obviously if I look at the air grid. And as you can see at the moment the directories are empty. What I want to do is I want to clean them and put into one file and put into the clean folder, which I'm going to go through in my script as well when I'm showing it to you line by line. time, I'll exactly show you how the files will be getting saved and where they're getting saved. So the idea is once these 3 files are created, which is the clean version of the files, and they are also in the same, so say for example, I'll give you one example as well, because when I'm looking at the files within, so wind speed was actually working on meter per second, and I wanted to change that into knots because in the other file I have the value in knots. So all these kind of changes I wanted to look at and just make sure that all the data is on the same level. It's coming from the same, like different sites, and they're all combined together in base of all the columns, and then all the file is basically clean, and there's no variables that are not really, like say for example, if I'm looking at integer columns, there's no string values and stuff like that. So I wanted to clean all of them, and in the end the idea is once I have these 3 files, concatenate them all together and have it on the same level based on, so what we are doing is we're looking at 1 hour interval files. So 1 hour interval should have all the input variables and should have my demand variable, which is my target variable. So without wasting any more time, let's kind of jump into the code and we go through the code line by line, and then we're going to execute the code and see what output comes out of it, okay? So if I look at first of all, so we are obviously getting all our dependencies. I'm basically importing all the libraries that I'll be using in this class. And then I have my class, which is project feeds. I do have my initialization function in which, first of all, I'm initializing a couple of directories that I'm actually pointing at. So as you can see, first of all, I have one directory for each of the location where I'm going to save these files in. And as you can see, the metadno goes to metno folder, and methern goes to the methern and the ergot. And then I also have this variable, which is check extension. Now, check extension is only because what I want to do is when I'm doing a for loop and I'm actually going through all the files, because I don't want to go through every file one by one. I'm going to kind of loop through all the files and to make sure that all the files are in similar format and there's no multiple files accidentally saved into those locations. So what I want to kind of do is I want to make sure that the file extension is .csv, so I'm only importing all the CSV files in my code. Okay, so once I basically put that variable here, what I'm doing next is I'm creating first of all function, which is I'm actually going to clean all my historic methern data. So I'm creating a data frame, first of all, empty data frame, and I'm basically going through a for loop. Within this for loop, if you see what I'm doing is for file name in OS list directory, and then that will be the methern folder, which is the methern folder as I mentioned in my initialization function. And so what I want to do is I'm basically defining this location because that's where I'm going to be reading the files from. So what I want to do then is I'm obviously going to print the name of the files because I do want to see them printed here, that I can make sure that all the files have been picked up. Okay, then I want to kind of read all my CSV files based on this download path. And how I'm actually creating this download path is, if you see, first of all, I'm defining an empty string. But then if you go back onto this download path, what I'm actually doing is I'm doing os path.join. So I'm joining 2 paths, one which is my methern folder, which is, as you can see, I'm talking about this path here. So I'm joining this path with the file name. So file name is referred to the actual extension we're using in the loop. So for file name in the list directory methern folder. And as you can see, what I do in my next line of code is that if any extension, so when we say any extension in file name, for extension in self.check extension. So what that means is that first of all, the extension of the file should be equal to check extension, which means it should be .csv. And then I'm basically taking the file name itself. So extension in file name for extension in check extension. So then I'll take that file name. I'm going to print that file name. Then I'm going to join that file name with the location. So I always have this absolute path for all the files. And that's what exactly this call tries to do. Then I'm going to read that file. So as you can see, we're still in this for loop and we're still in this if condition. And what I'm doing in here is basically defining the column names, because I've seen that some of the files actually have some other columns as well, whereas this data is not there in a couple of files. So I don't want to use more and more features, but those features are actually not existing in the other files. So I want to make sure this is all standard. So I'm using all these standard features. That's one thing, and then I basically define that these are the features I'll be working through in my model. So these will be my input. So within this, what I'm actually doing is df is equal to data and data.columns.intersection. Basically, I'm selecting only the columns that are basically selected based on my selection criteria here, which is the actual column names, because these are my inputs of my model. Okay, so then basically what I'm doing is I'm adding this suffix to the columns. Why I'm doing this, because as you can see, like I do have 25 files. So what I want to do is, because the variables would be kind of same name. So as you can see within these column names, I do have same names for all of the columns. So what I want to do is I want to add a suffix to each of these columns depending on what site we're working with. So why I'm doing this, and sorry, how I'm doing this is basically, if you look at column string, which I'm doing is the actual file name, which would be the file name coming from the loop. I'm replacing obviously the .csv, which is replacing the extension with blank. Okay, so then I'm creating this df columns, which is again name of all the columns. And how I'm doing this, first of all, I'm leaving the date the way it is, and then I'm adding this date with the new columns, and I'm doing it based on list comprehension. First of all, I'm basically looping through this. So as you can see, what I'm doing is for call in a df.columns, which means df is this one, and I'm looking at all the values within this data frame, which is df, and I'm basically taking all the columns if the call is not equal to date, because I want to leave the date the way it is. But for the rest of the column, what I want to then do is I want to basically take the call name itself, add it another underscore, and then add column string. And column string is the name of the file. So based on using list comprehension, I'm looping through all the columns and renaming those columns with adding an extension in the front end of the file name. So that's basically exactly what's happening in these two lines. Basically after that I'm passing out of the if statement, and as you can see in the end what I've done is I'm basically taking that meta file. Now because as you can see this is outside the loop, so we have looped through all of those 25 files, and now we have basically consolidated into one file, which is this one data frame, meta data file. Then what I'm doing is I'm os.join because I want to join now the actual folder location with the new folder that I've created, which is clean_data. And within that subdirectory, then I'm actually going to name the file as metairndata.csv. And what I want to do then is basically save based on that. And I'm also making sure that index is not saved, so index is false, and I'm writing it as CSV. Now, for your condition, you can use the same function, but if you want to actually save the data not in a CSV file on a data frame, you can write your call here to actually save it into a database. So hope that kind of explains out all the process of meta-data, how we are doing this. Now we move towards the next function, which is metno_data function. Now kind of it follows kind of same pattern, but I know that there are a couple of complications in terms of the data is on a different level and the data is slightly different. So I just want to make sure that we are using it on the same level, because when I was working with meta-data, I did have these values as like the short form of each column, but when I started working with metno_data, I can actually exactly see that some of the definitions of the column is different. So I want to make sure I'm actually aligning these two together in the same way. So as you can see, if we move toward into it, first of all, we do have same 25 files in that location as well. So we kind of follow the same step. We create an empty data frame first, then we give a blank string for the download path, and then what I do is for file name in the list, basically os.list directory, basically I'm going to do it for metno folder because we do have 25 files in it. What I want to do is I'm going to be looping through all the files as it is a for loop. Within that for loop, the first if statement, what it tries to do exact same what we did before, checking the extension, if the extension of the file is .csv or not. Then secondly, what I do is I'm actually printing that file and then creating this download path, which is again, as you can see, if you're following the same structure that I exactly explained in Metairn. And what we're doing is we are basically reading those CSV files, and then I'm basically selecting the columns that I want to see, because then I'm going to run this command, which is data.columns.intersection on that column list, which is the list value where I have all the column names that are equivalent to the column names that is in the previous file, which is the Metairn file. So once I do that, then I'm going to move towards the next stage, which is I do have to reformat some of the data variables. As you can see, what I'm trying to do here is, because within the metno file, I did found that they actually present the unit values also with the data points, which I don't want to do that, because as I've seen in the Metairn file, I don't have any unit values, I only have my data points. So exactly same way, what I'm doing here is I'm just replacing any sort of unit values, which is if like the pressure is mentioned or if the Celsius is mentioned in temperature column, I'm just basically removing them step by step because I don't want to have that into my data values. And so they're not connected to each other. And as you can see, I do that for all the columns. And as you can see, there's one extra step I do in the wind speed column. What I'm doing here is, because my wind speed is in meter per second, and whereas if I was looking at the data in the Metairn file, it was in knots. So I'm converting that value from meter per second, and I'm basically multiplying it by 1.943844, which is unit of measurement conversion from meter per second to knots. And that's what exactly I'm doing here. Finally, once I'm done with all of these columns and I've actually taken off all the unit measurements from the data points, so my data is only in the data points only, which is I can then convert them into an integer columns, and I can have those values exact same format as Metairn file. So once I do that, then I'm kind of like renaming the columns, because I'm trying to basically standardize my data. So anything that's been mentioned, say for an example, as air pressure at sea level, should convert it into MSL, air temperature is converted into temperature. So I'm actually bringing the same column names that I had for my previous file, because I want to make sure all the column names are exact same in two of these different data location points. And then what I'm doing is I'm basically adding I'm doing the same work that I did in the Metairn files, which is adding this, first of all, creating this column string variable in which I'm actually using the file name and replacing, basically taking off the .csv in front as an extension of the file. I'm taking that off. Then I'm creating these column names, which is I'm leaving the data as it is, and then I'm using list comprehension to basically add this file name extension in front of all the column names. And that's what I'm doing through this list comprehension call. Then what I do is, because we're in the loop, and I want to make sure when we're on the first time in the loop, it should just save the data frame into the file name, which is the data frame variable here, main metano underscore data. And if that has gone through one time in the loop, because it has to do that 25 times, because there's 25 different location values. So what I'm doing then is, if that file already exists in the first one, then when it loops on the second, so if it loops first time, it's actually going to say just the data frame in it. When it loops the second time, because the length of the metano underscore data is not 0 anymore, it goes to the else statement, and then what it does is it basically merges two files together, which is metano, which is the first run of the file, with the new df column on the second loop through file. And then what I'm doing within that is I'm doing an inner join based on the date column. Once I do that, then I do have to follow this same step, because our method files, because it's kind of like I'm thinking advanced in because once I'm actually automating these files, once I'm automating the scripts, which is to download these files from API. Now I could be running these files every night. When I'm running it every night, it always gives me the data for the next 2 days. And what I want to make sure is when I'm running them, I don't have any overlap of these date columns. So I always want to take the last entry that I took from the last API call. So what I want to do is, first of all, I want to sort the values by the date column. When I do this sort values by the date column, then I do have all the values in an ascending order for the date variable. And then finally what I do is I drop the duplicates based on the subset of date and keep the last value. So as you can see, like, it follows kind of similar steps towards the meta file as well. And then finally I just save the files into this clean data location. Once I do that, then I move towards the air grid data. Now, as you can see, like, the idea is kind of same. The idea is always the same, that there is files in these folders, go through and loop through all the files, so we're not doing them separately. Take the data, clean it a bit, and make sure that it is in the right format, what we need. Then basically combine all that, make one file. And that's what I kind of explained at the start as well. That's my plan, to take all these 25 files, generate one file, take these 25 files, generate one file, take the 4 demand files, generate one file. So finally, in the end, I can concatenate all of these together. So as you can see, with that, what happens in the air grid data as well, we create our empty data frame, an empty string for the download path, loop through all the files and printing all the file names here. And then finally, what I'm taking as a list column is my date and demand. So once I do that, then I'm reformatting the date in this case, because I know one thing that is existing in my demand files is my demand file is on 15 minutes interval, but my rest of the data for the weather is on 1 hour interval. And that's kind of what I want to get at as well, because I want to predict for every hour, not for every 15 minutes. And that's what you can see here I'm doing here. First of all, I'm converting this date column into a date time column. Then what I want to do is I want to create them into an hourly. So I'm grouping them by date, frequency is hour, and how I want to group them is by taking the average. So which is I'm doing with the chaining method, I'm doing dot mean and rounding them up as well. So if there's a lot of decimal values, I want to just bring them into only one decimal value or no decimal values. Once I do that, then basically I'm like going through the file, and then I'm actually resetting the index, which is, and then I'm also setting my column names, as you can see. So first of all, I'm actually looking at my date column, and because my date column right now is the index, so I'm saving that as index is saved as date. Secondly, then I'm looking at my data frame, and I'm only selecting the values, which is date and demand, and putting that into a df, which is my data frame variable. And then I'm resetting the index and deleting the previous index. Then I'm kind of doing this exact same thing which I did in the previous two functions as well, which is first of all checking the length of the main air grid data, and if it's then doing for the first file, because then the length would be actually 0, so we won't really kind of like concatenate two files. We'll actually save that into a main air grid data file. And then if I'm actually on the loop on the second time, because I'm looking at the second file now, so when this is false, because length is now and not anymore 0, then we move towards the else statement. Whereas you can see it's slightly different to the previous command, because when we were working with the weather files, the weather files were actually for the same date, wasn't really for different dates. It was for same date, but it was 25 files for a different location. So it's the exact same way when we are looking at the air grid data. Then now we have 4 files, but these 4 files are for separate days. They're actually for separate years. So what I want to do is I want to actually concatenate them rather than merging them. So we're not doing any inner join in this case. We're just concatenating 2 data frames, which is main air grid, which is from the first call, and then we're concatenating that with the new df, which is the second run of the loop. and the axis is equal to 0 because we don't want to save it like side by side. We don't want to save it by row level. We want to save it on a column by column level. So it will be the first data frame and then the second data frame on the next. So that's how we are saving it. Then finally, I do to make sure if I've run this file a couple of times, and if there is any duplicates, just remove them as well, and which we do it the exact same way. First of all, we sort them by date, ascending through, and then secondly, we just drop duplicates based on keeping the last value. So once we do that, then we actually basically do OS.join to save it on the exact location, which is the clean data. And then we finally run this, and index is not saved, so we just then create a new CSV file. Now, as you can see, so far we have done kind of similar, but there is slightly difference in these files, in these functions as we have mentioned. And now we have our, so for an example, how far we have got is, we have our 25 files from Metern is converted into 1. We have 25 files from met.no is converted into 1. We have 4 demand files, which is converted into 1. So now, ideally, we have only 3 files to move forward to. And then finally, what we are going to do is we are going to do data mapping, because we have now 3 files, and our goal is to bring it into 1 file. So what we are going to do then is, first of all, I'm actually, because this is kind of manual stuff, because these are all the name of the columns that exist in these files. And while looking at these files, I also saw that on some of the locations, like which were the offshore locations, I didn't have full data. So the data was incomplete for those locations, which I took off. That's why we ended up with these 25 files. And once I've done that, as you can see, I'm just mentioning the name of the columns because I'm selecting these columns and removing some of the columns that I don't want. And so as you can see, these are my this is my date, and this is my weather location for all the location we have actually picked up from our data collection stage. Secondly, I'm just reformatting my date column within the data 1, and that's my data 1, which is my Metern data, and data 2, which is my metno data. So as you can see, our columns are exactly same because I wanted to kind of make sure that they will have exact same columns and exact same placements of those columns. That's why I've kind of like manually mentioned these column names. And once I mentioned these 2 data files, which is data 1 and data 2, then we are going to go back into and concatenate these 2 data files. So as you can see, what we have done here so far is we have our weather data. Now, as you know, like, because Metern data is looking at historical data and metno data is looking at future data, so now these files can't be merged together as an inner join. They have to exactly same. They have to concatenate with each other, and they have to kind of like stack up on top of each other. Like, so if we have our first stack, which will be the data 1, which is Metern data, which is historical data. Then we have this metno data, which is our second future data, which is again when every time we click it and every time we get the data from the API, that says for next 2 days, which we are going to be stacking on the other data. And that's what we are doing here through concatenate, where we are saying x is equal to 0 because we want to concatenate on and we want to stack it onto the other one. Once we do that, then we are basically just reformatting our weather data file, and then the time we're converting into to date. And secondly, what you can see here is we are actually sorting the values because we just want to make sure when we have stacked on top of each other, if for some reason the values are not sorted, just to make sure and be confident that yeah, they are sorted in the right order. I'm just going to sort them by ascending order. Then finally, I save this weather data file as a CSV file in my data location as weatherdata.csv. I'm not saving any index in this case, but as you can see, first of all, we're just writing one file, which is weather file. Now you can see we haven't really merged the demand at the moment. So these are only my input variables at the moment, and I haven't really concatenated with my target variable, which is my demand variable. So we are going to do that next. But you can see here, first of all, what we are doing here is we are reading the air grid file, which is our main cleaned file, which is within this file name, which is airgrid_data file. Then what I'm doing is I'm just basically converting my date into to-date time into write format, which is the format that I have also looked at in the previous files. Then what I want to kind of do is create my final data set. How do I create this is actually because now, as you can see, we don't really have to concatenate these two because they're not going to sit on top of each other. It's actually the weather itself is my input, and then demand itself is my target, and they are for the same time frame. So I'm going to merge them and make sure that I have demand for all these input variables. So in this case, what I'm doing is I'm actually merging them together, and which I'm merging through weather data and my data 3, which is my demand data. And I'm doing an inner join and both on the date variable. So once I join these based on the merge function. Okay, so then what I'm doing is I'm actually converting objects into floats, because I just want to make sure if there is any sort of white space in any of these columns or any of these unit values are in white space, I just want to make sure all the data is in the same format, that I can actually just plug it into my EDAs and plug it into my model. I don't really have to do any more so like data cleaning point in this case. Okay, so what I'm trying to do this is like I'm actually trying to convert object into float. So that's what I'm doing through this call. First of all, I'm looking at any columns that have data type as integer, save it basically into this data frame, which is project data integer. And similarly, if some columns are an object type, save it into this data frame. Why I'm doing this? Because I just want to make sure that all of my columns in the input and in the output even, they all are in the same format, which is the float values. So that's what I'm doing here. Any column that is an integer, I'm converting them into float values through using lambda function. Similarly, then I'm actually also looking at columns that are in the object format, which is the data type object. One reason why they could be in object format is there might be white spaces in it, so I'm removing any sort of white space that exists in any of those columns, and then I'm converting into, same way, using the lambda function, convert them into float. Once I do that, then what I want to do is I want to save the location where I'll be saving this project underscore data.csv, and then basically index, I won't be saving that, and then finally I make that call and then I save that as to CSV. So finally in my main call, then I'm basically initializing my class and then running all these functions, which is run first of all metturn file, which is to save the 25 into 1, then metno file, save the 25 files into 1, finally run the error grid, which is converting the 4 files into 1, and then finally running the last one, which is going to be data mapping, which is going to be saving that into a 1 location while we are looking at all these 3 files and converting them into 1 file, which is project underscore data.csv, and then save that file. Then I'm actually just initializing this data frame call as well, just to make sure that so we can actually view how the data looks like. So what I want to do is I'm actually going to go ahead and select all the code and just run it. Okay, so as you can see, my function is now completed. I have all my data cleaned. So as you can see, first of all, we started with cleaning all the historical data for the 25 sites. Then we started cleaning our forecast data, which is for next 2 days, which runs slightly faster. Then we have our demand data also cleaned. And as you can see, we have our one data frame now created here, which has 57,696 rows and 173 columns. I do want to open it as it is a white data frame. So as you can see, everything is now in the same input. I do have my date column, which is on an hourly level, and then I do have all of these multiple sites. And if I go around on the end of the file, I do have my target variable as well, which is demand. So we are finished with the cleaning stage, and what I'm going to do next is actually show the file on my location as well. So as you can see, if I look at in the clean database, we should have our files now. Yep, so we have this one. Similarly, we should also have it for met here, and we should have one clean file, perfect. And similarly, we should have one for metno as well. So if I go into this one, and as you can see, that we have our file here as well. So once we have saved our files, and finally, as you can see here as well, we have our 2 main files. One is which is metadata, which is all just the input variables, and then we have this project data, which is combination of input and the target variable. Okay, so what we're going to do next is I'm going to git commit on this, just to make sure we have uploaded all this values as well. So I'm in my folder location here. Perfect, so we have added all the files. I'm actually going to do git commit. And we have committed our second file. As you can see, we have our old insertion of different files, which is again our CSV files and our actual code file. So once we have saved all that, what I want to do is I want to just git push it onto the directory. So once I do that, it should be pushed to the repository that you can have access as well. So you can actually, I'll be leaving the link below anyway, so you can actually open it through that, and you can actually access all the files and all the code file as well for the data cleaning. But the next stage would be more interesting because it will be more interactive as well, because this one was quite straightforward, which we actually just started cleaning the files and we wrote our main class to actually clean all the database and bring it onto the same level. In the case of the next one, which is the exploratory data analysis, what we will be doing is we will be looking at how to, for this actually we'll be using not the Spider IDE, we'll be using Jupyter Notebooks. And within the Jupyter Notebook, I want to actually elaborate more with the Plotly graphs, and we should look at around how we can actually use all these multiple things and see what exactly the data is telling us. And I'll also run some basic models beforehand to see if it's good to have these kind of multiple features for each site, or would it be good to actually maybe combine them all and bring it into one column and then see if that adds on more value and if that helps the model to predict more accurately in comparison to using multiple site way. So stay tuned for the next video, because the next video is going to be really interesting, because we'll be looking at doing feature engineering and looking at the data points and how the data is actually explaining and would be more useful for the model, doing correlation analysis, and also looking at different plots and really understanding what data is exactly telling us. We'll also be looking at different features that will be coming out from feature engineering, and also looking at if there's any outliers in the data, how do we fill the missing values, because then all of that will then be inputted into our modeling stage, where we'll be actually starting to do different model techniques. We'll apply different model techniques on our data to really understand what models works the best on this type of data set. Once we do that, then we'll move towards the productionization of the model. So this is kind of like the summary I'm just giving it to you now, where what are the next stages of data science project from scratch. So I hope you're enjoying this project series, and I'll see you in the next video. Peace out.